Hi, in this video, I will be showing you problem number 4 of the worksheet on chapter 3 for the intermediate algebra class. Objective: solving a 2 by 2 system of linear equations that is inconsistent or consistent dependent. Two systems of equations are given below. For each system, choose the best description of its solution. If applicable, give the solution. So there are two equations. First, we will understand the meaning of system being inconsistent. If there is no solution in the system, then it's called inconsistent. Consistent dependent means one is dependent, one equation is dependent on the other. So when you try to solve, you will get a true statement, either 0 equal to 0 or 5 equal to 5, something like that. Then if you get a true statement, the system will have infinitely many solutions. That's what we mean by the system being consistent dependent. So in the following two equations, we are going to try to solve it and we will see what solution we get. For first equation, we'll call it equation 1, first set of equations. We'll call it equation 1 and 2. We will use the addition method or the elimination method. So normally if the coefficients are not equal and opposite, we will try to make them equal and opposite. But here the coefficients are equal and opposite already. So add the two equations. You get 0x plus 0y equal to 0. Which means 0 equal to 0, which is definitely a true statement. If the system ends up with a true statement, then the system has infinitely many solutions. So the system has infinitely many solutions, or it can also be described as the system is consistent and dependent. And they must satisfy the following equation: y equal to, you can solve for y from any one of the two equations. If we solve for y from equation 1, so we get negative x plus 3y equal to 9. So if you isolate the y, you have to move the negative x to the other side. That will become positive x. Now you divide both sides by 3. So if you divide by 3, you get y equal to 3 plus 1/3 of x. Or you can write y equal to 1/3 x plus 3. You can also write x over 3 plus 3. X over 3 can be written as 1/3 of x as well. So the solution, I don't have sufficient room for the box, so I wrote it separately. Y equal to 1/3 of x plus 3. The system has infinitely many solutions. So the solution is infinitely many solutions, and y can be written like that. Now for the second problem, there are two equations given in the system. In the second equation, the constant also appears on the left hand side, so we will move the constant to the other side. So the second equation is negative x plus 3y equal to positive 3. So first equation we don't have to do anything. The second equation we are moving the constant to the other side. Now you try to add the two equations, add equation 1 and 2. So you get x and negative x, that will be a 0. Negative 3y, positive 3y, that will be a 0 as well. If you add the right hand side, it becomes 3 plus 3, which is equal to 6. Unlike the earlier problem, in this case, 0 equal to 6, which is a false statement. Because it's false, the system is inconsistent. So the system is inconsistent and it doesn't have any solution. So in this case, you would say no solution. The system has no solution. That is the solution. That's how you write the solution. The system has no solution. Whenever the system, when you try to solve, ends up with a false statement. Then if it ends up with a true statement, the system is consistent dependent, and then there are infinitely many solutions. Hope this video helps.